Hey, Mackenzie, thanks for joining today. Super fascinating topic for the next 30 minutes. To get going, do you know today how many AI agents you are using personally for your day-to-day work?
Um, you know what? I kind of typically try and stay away from agents myself because they kind of freak me out a little bit when it comes to there. What I typically been doing mostly is I have a lot of agents that I run in sandbox environments for testing for security purposes. But especially with things like OpenClaw that have come out, I'm kind of freaked out by the AI agent revolution that's going on at the moment. I'm excited to watch it, but I'm also like quite cautious.
Okay, let's get into that and why you are sort of also freaked out about it. I thought this was really interesting what we've observed in the last, let's say, 2 weeks. Like
Mm.
security folks have been going on also with regards to security questions around agent access, but obviously the world was super hyped by the efficiency gains and what AI can do, and then this OpenClaw thing suddenly changed the tone, right? Um, so let me phrase the question like this. Why are we speaking about this today in your perspective? Like, why is there a security topic around agent and AI agent access?
Yeah, I mean, agents are kind of like the ultimate non-human identities when it
Yes.
comes to this. There is a hacker that I know really well by the name of Len No. And this is gonna feel like a little bit off topic, but I promise I'll bring it back to why it's relevant.
Sure.
But Len No is what you call he's like the world's first augmented human hacker, which basically means he has about I think he's up to about 14 different microchips implanted in his body to be able to give him enhanced hacking abilities. And when I've been kind of discussing aspects of security with him, it kind of being hacked when you have embedded technology like has a completely different meaning to it. So like you could take let's just say when you have these crazy technology developments in kind of human space like Neuralink, all of a sudden you think, gosh, imagine if someone could hack that. And this kind of was like a theoretical problem that we had kind of in the future if all of this technology went forward. What kind of happened this year in particular is realizing that you don't need to have embedded technology to be able to like hack someone themselves because their agent is almost like a proxy of them. So part of the security concern is me is if I have embedded agents, let's just say in my phone or in my embedded systems, in my emails, then if someone is able to take over that agent or give it malicious instructions, I think is kind of more likely, then all of a sudden it's kind of almost like you've been able to hack me in a sense because agents can have access to the same things I have access to. And whilst that may not translate into a physical world, it's kind of more important that it doesn't translate into a digital world because that's where me in particular I spend most of my identity. So that's kind of what freaks me out. It's like I know we took a little bit of a detour there, but I just kind of like thought I'd bring it. It's kind of like hacking a human in a way, and with all of these permissions that agents can have, then that kind of like feels like a very big vector. I will point out too though that I'm definitely not against the technology. I'm very cautious of it, and there's certain reasons why I am in particular cautious of it. I'm enjoying watching it. I'm enjoying seeing the technological breakthroughs. I'm just, as I said, freaked out by it.
Yeah, I can definitely see why you're freaked out there. And let's go further into LLM guardrails and permissions of agents. Let's quickly get because there's also if I at least read LinkedIn, it feels to me like there's a lot of confusion around, let's say, terminologies. So you just mentioned non-human identities and AI agents, and sometimes they are like used simultaneously or mixed up as synonyms. In my perspective, they are ultimately not, right? I mean, non-human identities have been around for a while. It's essentially machine-to-machine
Mm.
access. You connect two SaaS systems, and you have essentially, if one of them can modify the other one, you have a non-human identity already. And AI agents are really a subset of that, right? So I can use an AI agent myself just for me, making me productive, as long as it's not connected to another piece of software. It's not a non-human identity yet. But if I, of course, give an AI agent permission to connect to another piece of software, to read it, potentially even to modify it, then I have really an autonomous non-human identity that can access other systems. Is that a sort of definition that you would agree to?
Yeah, I mean, absolutely. And I think the identity kind of component in that is also like really important in the sense that how we identify, authenticate, and authorize all of these different machine to machine community, and kind of agents, even if they're not AI agents, I think you can kind of call lots of things like different agents. It's really how the world interconnected, and we've been down this shift for a while. Like we started off with digital passwords that humans would use. We transformed into kind of certificates. Then we created API keys. And now we're into this world of kind of autonomous agents or AI agents that can be embedded into multiple different things, communicate in multiple different ways, change different systems, all without kind of without kind of further instructions, if you will.
Exactly. Now, I've heard a really interesting researcher from San Francisco the other week, who's in AI governance, and the point that he made, and I thought that was really compelling, is that he said many of these specifically LLM models sort of established the promise that you can ultimately secure access to guardrails, but guardrails won't work because there's almost always a way to sort of trick a probabilistic model into ultimately doing something that it's not supposed to do. In other words, the only way to secure an agent is through proper permissions. What's your take on that? Like, if you just said you're only using them in sandbox environments, and I totally get that point. If you were in a position you really like something and you really want to use it now, how would you set up the sort of permission logic around it in order to secure that non-human AI agent identity access?
Yeah, well, first of all, I totally agree with that statement around the fact that, I mean, these AI agents are basically susceptible to social engineering, so therefore, there's always going to be ways around that. But when it comes to actually like securing it, I think there's a couple of things that are really important. And to me, it comes a lot along with authorization and the longevity of access. So, we take it like access being, can I access a certain system that I'm using? Do I have an access token for that? And if we start there, it's kind of saying, how do you define those access tokens that they have? How long do they live for? And how does the agent kind of request that and get access into a system? The biggest mistake that I can see people making with these systems is having these long-lived access tokens in their agent, access tokens that don't expire. Agents kind of can agents being able to be socially engineered, it's quite common for them to inadvertently leak the access keys that they have in them, especially if they're not kind of set up correctly. So making sure that those access keys don't actually get leaked, and the best way to do that is to make sure that they don't live very long, the short as possible. Ideally, having dynamic access, which is basically they request access to perform a task. That access is given for that task, and then access is revoked once that task has been solved. Now, unfortunately, this takes a lot of setup, right? This is not necessarily a default thing to do by any means. If this component could be guaranteed in that dynamic access, I immediately would be way more comfortable using agents for sensitive systems, And when I'm talking about agents, I'm really talking about having systems that are kind of somewhat separated from me and not just kind of using an AI model. But if we go into the second part of that, it's kind of like authorization. What else can those agents do? And the other kind of crazy thing that you see out there in the wild is the God status that is given to these agents. So, you want your agent to be able to gain access to your email system, or, a very popular one with OpenClaw is like giving it access to stock market brokers, like Polymarket or something like that. So what they do is they generate long-lived access tokens that are basically authorized to do everything that you can do. If that token leaks, or if that agent is turned malicious, and we can talk about how an agent is turned malicious because it's a very real threat at the moment, then that agent has access to everything that you has, and that goes back to the fact that it's almost like you've just hacked me now, because now I have all of the access that I have access to in the digital space, and a system that can act on my behalf. So they're like that, like access and authorization. Which is, it's kind of interesting because these are the two things we've been struggling with in security since the inception of the internet. Like, broken access control is still the number one vulnerability on all applications, so like, yeah, we're talking about the same thing, just in kind of different technology. But like, definitely, like, those two areas, if you can kind of solve that, so that you can really tightly control what your agents are doing, and if they go off course, then they don't have the access to do that. So, your agent is authorized to, to kind of read and summarize emails, but it doesn't have an access token to be able to send an email. Immediately, that changes what can happen if it's turned malicious. Still not great, but at least we can kind of control it.
Yeah, it's super fascinating, the point that you're making there. Let me quickly summarize. So essentially what you're saying, we agree that guardrails ingrained into LLMs will not be a way to sort of prevent them from going off and tackling the access challenge. It's a probabilistic model, and you can always trick it. There are million ways to do that. I totally agree that at the end of the day, the permission challenge needs to be done through sort of job-specific, dynamic authorization and authentication and authorization to carry out a certain task. And that's the only way to kind of to also where I would feel comfort to implement an agent. What's really interesting, though, is you said, like, obviously also for human access, like getting access permissions right is still a massive challenge. Now, we are taking the approach from human access, though, now, and are applying it to authorize agents, right? I mean, many agents you can authorize with OAuth, and that's a static permission, right? You're using almost the human authentication method to give the agent permission, and then it's static. That's what you just said. Or you're taking an API key, but that's the same outcome. Then you have that static, super broad permission. And sometimes there are even multiple humans behind an agent that can now, through the agent, access systems where they normally wouldn't have access. So building this dynamic access method is a very complex beast, though. How would you get going with that? How do you think that can be sort of cracked technically?
Yeah, so there's some frameworks that are kind of starting to be built around this. I think kind of, if we look at it practically, there's a couple of points immediately that you can kind of look at. One is to make sure when you're not sharing access to amongst different agents. So I think something is really important is, same principles apply back to systems and API keys. Don't generate one API key and give it to a whole bunch of different systems, because then closing off access to that one thing can close off access to everything, or vice versa. So I think if you've got multiple agents doing multiple tasks, even if they're interacting with the same systems, make sure that every agent has its own identity, so that you have control over that. I think the next one's kind of like, seems like very typical, but like principles of least privilege. It seems silly that you have to mention this, but like, it's, especially with agents, it's like the biggest thing that I can kind of think of as where things go wrong is that you build a specific agent to do a specific job, and then you give it access to do everything. So, like, that shouldn't be doing it. If you have an agent that can read an email, that's the only thing that agent should be able to do based on its permission identities and its authorization for that. It should not be able to do anything else in that. So like principles of least privilege. It's a long-standing security rule, but it's one that like absolutely absolutely kind of needs to be applied in here. And I've already kind of talked about like dynamic secrets or just-in-bound secrets, just-in-time secrets, and these are kind of like creating things of not having long-lived secrets. With agents, you have risks of them going rogue, of them being turned malicious, of them having over permissions, but there's also the risk of them leaking their access through various different methods. So trying to limit that method, and technically this is actually quite a big challenge, because in order to be able to do this, you need to have it connected to a system that can communicate, like, which often has kind of a superpower secret, to be able to generate secrets and then pass them to the agent. So there needs to be a management piece that is managing those secrets. And these pieces do exist. You don't need to build this, but it is like technically, a hurdle. And I think this step here is kind of probably one of the most important ones, especially if you're giving it access to very high privileged systems or services. I kind of think that they're probably the key things, from a technological point of view to start tackling first, before you can kind of be very comfortable in kind of letting your agents out into the wild and letting them do things.
I agree. Yeah, it's very interesting. At the end of the day, and you made that point earlier, it's actually applying like concepts that we've seen in human access control for a long time and applying them to agents. And yes, just-in-time dynamic is probably the centerpiece. I'd be really curious, and this is almost a philosophical question. I mean, I know you worked in non-human for a long time in your pre-Aikido times. You were with GitGuardian, and they also help companies manage secrets and non-human identities in infrastructure and so on. So, Mackenzie, let's assume we build this setup that it helps us to kind of give agents job-specific, dynamic, non-static permissions in a very sort of accurate manner. Do you think in, let's say, 12 months, 24 months, will this permission management, this dynamic permission management, be done by agents, or should there be a human in the loop? How do you think about that? And what would give you more comfort to be less freaked out about it?
Yeah, definitely a human in the loop. And this goes back to the fact that the thing that is controlling the access shouldn't be non-deterministic. So like there's certain things in security that should be deterministic, which is kind of like yes or no answers, and not like, oh, maybe, and in this scenario. So LLMs and AI is famously non-deterministic, which basically means that like they're designed to have a variety of answers, and it's what makes them a unique technology and kind of gives them their power, but it also makes them terrible when it comes to security controls and access. So I think when you control the access point of view, which in my opinion is the most important part of having AI agents, that needs to be controlled by a human. Now that doesn't mean that a human needs to like accept and decline every single request that comes in, but it means it's in a system that is controlled by a human, where a human has clearly written rules that can't be socially engineered, like through an AI, like prompt injection to try and give it more injection. So, that this is kind of like one of the big key concepts. And, like a prompt injection is not a problem that, you can really actually, from a technical point of view, be solved without fundamentally changing how AI is trained and works right now. You can try and put guardrails up, but fundamentally it's not a solvable problem. And we can talk about that, but you should never have something that could be prompt injected controlling access, in my opinion.
No, that's what we said earlier, why guardrails don't work, right? In probabilistic models, there are a million ways to trick the model. So I agree. And I agree also to your intuition there, or to your take. probably can't be a human in the future that would sort of review every single request, but the human needs to be in the loop to control that system. And probably one theme or methodology from traditional access management that we haven't mentioned yet, access reviews, is probably also something that you really should do very regularly with agents, right? You do it with humans, so you should constantly review the permissions that you gave agents in order to implement least privilege.
Yeah, I mean, absolutely. And I think kind of like you could also separate it out as like what's kind of AI managed and what's rule based managed.
Exactly.
You know, like and the example I kind of to help that kind of helps me understand this, or at least I'll say that, is, I work in security, and a big part of security and application security is like scanning your code to make sure you haven't done a coding mistake that could end up in SQL injection or something like that. There's a whole bunch of new startups that have come out at the moment that are using AI to scan code for these vulnerabilities. I love AI and its kind of purpose in security, but one of the key issues is like there are certain things that should be rule based, and that's anything that can be deterministic. So, do you have an SQL injection vulnerability pathway or not? It's yes or no. But if you give that to an AI to make a determination, you ask it 100 times, it may give you like 4 or 5 different answers to that. That's the same with access. It's kind of like, should you have access to this thing or not? That's yes or no. That rule set can be defined by a human, and there shouldn't be any gray area like in that case. So deterministic. If you give that to an agent, it's non-deterministic, and all of a sudden you're opening the floodgates to like potential breaches in access.
Yes. With regards to floodgates, one thing I'd love to also touch upon, and we quickly spoke about that already. So obviously it's the agent itself that can access other agents or other SaaS. It has the permission to read. It has potentially permission to modify. Then there's one more dimension, and this will make this so complex in my perspective. There's still not only the human who should review it, but there's also still a human behind the agent, right? So if we almost think about the access matrix, it's humans accessing agents that might access other agents that might access other SaaS systems or pieces of software. How do you think about like this? Like, how would you control that from a governance perspective? If 2 humans access the same agent and maybe one of them set the agent up and the other one now suddenly gets the sort of the chance to also use that agent, this human can potentially through that agent see things where the human normally wouldn't have any direct access. Let's assume someone in the sales team connects some agent that can, I don't know, write messages with their CRM. Someone else gets access to that agent, but this person doesn't have direct access to CRM. So there's a big loophole now for the human, right? Even if this person is not malicious in the first place, through the agent. Yeah. So that makes the whole equation even more complex, right?
It does, and I can give you like an extremely concrete example of this exact scenario happening in real life. I was involved in kind of like a security review of an external company fairly recently, where they had some pretty serious kind of breaches that have impacted kind of some of their compliance issues because they had to report these breaches. How these breaches actually happened is they had Slack channels, and most importantly, they had Slack channels set up with external partners of them. So in Slack, you have your company. I can talk to my colleagues, and even in this case, there's issues. But then I can also talk to external companies as well. And what you can do is, if anyone that's dealt in a company that deals with Slack like this will know how quickly and crazy unmanageable it gets when you have all of these different channels going on of different people, and you do it. So great use case, take in AI agents to be able to help them do this. In particular, they had agents that the internal staff were meant to be using, which were actually to do with code reviews and only meant to be accessed by the development staff. But through broken permission structures, they had these bots that were actually available to external staff members, external partners. External partners quickly figured out that they could interact with these bots or these agents in the Slack channel and get them to give them the proprietary code of the company, because these agents had access to the code. So that's kind of like a concrete example, but imagine this with a couple more layers where you might have even more agents in between and going through, and you can quickly lose track of what all these different agents actually have permission to, what platforms can interact with these agents. So the whole system gets very, very complex, and you can see how this would happen in real life.
100%. Now, if we get very pragmatic now, there's no world where like companies won't implement agents at all. It's simply happening, and let's also be clear, it's extremely exciting that this is happening. I know Aikido is, for instance, very, very sort of strict when it comes to system access. But what will be your 3 to 5 very practical tips for companies that do want to enable their teams with agents and that are also realistic and say, like, my sales team, my marketing team, my finance team, they will simply do this. Yeah, so we can't stop the wave. Still, we want to do like an as good job as possible in order to protect and secure our environment. How would you get going if you are open to it?
Yeah, definitely. So you make an important point there that I want to like just double tap on, and that is like banning AI is absolutely not a solution, and should never be a solution. There's something called shadow AI, and it's basically, the draw for AI, and like I think everyone is using AI now, and if someone was to try and ban it, then all you're going to do is send your employees into the shadows, because the productivity gains are just too big, and you're going to feel like you're left out. It's kind of like in 2002 telling people that they can't use the internet for their, for their where they can't do research. They have to go to the library and take out books. It's like the exact same equivalent. So I think, just the first tip would be to, don't try and ban it. It's set up clear guardrails around, how these agents work and what they can have access to. Part of that, the best way to control what your employees can connect agents to is making sure that you can control what your employees have access to in terms of identity, credentials, and secrets and things like that. And so you need to make sure that the employees can't create these kind of long-lived secrets and give them to agents and let them do their thing. Controlling access at kind of a human level, I think, is definitely going to be like a fundamental way in trying to prevent this. I'd also make sure that you have clear guidelines on the risks associated, with these different agents and what they can do. And I would also kind of say right now, and I think, in a year's time, this advice will be outdated, but I think every advice for AI agents is outdated. But when you're talking about embedded agents, so there are ways to kind of use agents, like if you're using Claude Code for like certain things, those agents kind of are somewhat separated from your system, then that is one thing. If you're embedding agents within your system in the way that you can with OpenClaw, then it's almost impossible to embed something and then restrict access to it from within. So making sure that you kind of keep your agents external from your systems. Like, I think at this point, like, I cannot imagine a scenario where OpenClaw would be secure at this point. That's not to say it's not ever going to be, but just with all of the insanity that kind of is around there, I would say embedded agents into systems is not the solution. It's exciting, and I love to play around with them, but it's just not the solution for the moment.
Yeah. So probably, in other words, in the absence of the perfect solution, establish a 80-20 at least access control process. That's how I would think about it. Having a request and approval process to introduce agents, have someone review them and their security posture, restrict certain agents, approve other agents, and then make sure that if people introduce them and give agents access to other agents, as we've discussed, that it's just in time. And probably today it's difficult to implement something that in a fully automated manner is going to be completely dynamic. But then you need heuristics to make sure that you revoke access after a certain job has been done. Yeah, cool. Coming back to what you said earlier, that you're freaked out about it, and therefore yourself only use agents in your sandbox environment. What do you think? What's the next disaster that we're going to see in the next, let's say, 2 to 3 weeks? What's going to come?
Well, I think absolutely we're going to start seeing some big security incidents that surround the ecosystem around agents. So just to kind of like talk quickly about what is happening in the world of this OpenClaw situation, I think if we're talking in a time frame of 2 to 3 weeks, that's absolutely where the risk is, that the world is in this open source kind of agent OpenClaw. And the part of it is the ecosystem that's building around it. So there's something called ClawHub. And developers will immediately kind of be able to relate to this, because this is the equivalent of a package registry, which is basically, there's all these open source tools that you can have. You can download them from something like NPM for Node or PyPy for Python projects. Well, ClawHub is a registry for OpenClaw skills. So basically, you can develop a skill, which is a kind of a set of guidelines to help an OpenClaw agent perform a task. So for example, if you want OpenClaw to be able to trade on Polymarket for you, this is like the number one thing I'm seeing on Twitter, and it's just like, oh my God. I don't even want to talk about it. But there's all these skills that will help you connect to Polymarket. Spoiler alert, most of them are malware, but whatever. And that skill can list instructions of what to do, but it can also install things onto your machine. It can kind of set up dependencies for you and kind of get you sorted in it. So these skills are scary for lots and lots and lots of reasons. So number one, it's it creates the opportunity for a supply chain attack. So let's say you create a very helpful skill. Let's say, oh, God forbid, you create a skill to help set up Polymarket, and the skill works completely as you expect it. Then it becomes very popular. Then you do an update of that skill. Now that update gives malicious instructions or a malicious payload to OpenClaw. Now all of a sudden, that OpenClaw agent is malware.
And we've seen these cases already with these skills, right?
Yeah, about 20% of all the skills on ClawHub right now are just blatant malware. And what's kind of scary about it right now is that all the malware that is on there that we're seeing is just dumb malware, by which it's an example of a Polymarket one. Seen, I'm on this bloody Polymarket train at the moment. But there was a Polymarket skill where it ran the skill, and then a little pop-up came up and said, hey, in order to trade on Polymarket, I need to install this dependency. And so you click OK, and then it installs malware.exe, or whatever. And then now you have a backdoor into your machine. That is effective, but kind of dumb in the sense that it's the easiest thing that you can do.
Absolutely.
Just try and get someone to deliver a malicious binary. With all of the hype around this OpenClaw business, that there are APTs everywhere that can guarantee there is a room in North Korea right now filled with the Lazarus group of them trying to figure out how can they write sophisticated malicious skills that will avoid detection. So in ClawHub right now, they've just teamed up with Virus Total to help scan for some of these malicious binaries. Great first step, but that's not going to stop an actual malicious skill. And then you start putting in some prompt injection into there. You discard that. Maybe you have prompt injection in non-printable characters. There's something called Unicode characters that can be invisible and non-printable on screen, but can be interpreted by machines a different way. That could have a prompt. There's just so many ways that this could be turned malicious that is much more sophisticated, and we're getting started. And we've opened up the cat and mouse scenario now. And I think part of the problem with OpenClaw, because I've talked about it a lot and I sound very against it, and there's certain things that I am kind of against. But part of the problem is not necessarily OpenClaw. It's at the speed in which we're adopting this brand new technology that has absolutely no security guardrails on it, because like it's only a couple of people that created this. So like kind of, you know, they can't create security guardrails at the scale of the entire freaking world, which is kind of like where we're at. I'm getting on a bit of a rant now, so I'll calm down.
No, I get that rant. I get that rant. That's what we're here for. But look, I mean, to summarize, I guess the key takeaways is we both agree no one will and should stop companies and teams and employees from implementing AI agents. No way in the world that's going to happen. Still, it's very obvious that you can't protect and secure them just through LLM inherent guardrails. You will need to implement dynamic access controls in order to protect their access and to revoke their access. And last but not least, I mean, that's what I find so fascinating. Why all of this is happening and why everyone is so hyped. Some people simply forget about some very, very basic, not even security, but I would say common sense things that you would never do in a physical world. Yeah. And here you're just so hyped that it's open house and open door. Mackenzie, the one of the most interesting. This was really a pleasure. Time is flying by. You said like the pace of innovation here and the pace at which things are changing is insane. Probably in 2, 3, 4 weeks from now, we'll have learned tons of new things. So as a little cliffhanger, there's going to be a follow-up on this one between the two of us. For now, thanks a lot for joining today and taking the time. This was really, really fascinating. And let's see what we're going to see in the next 2, 3, and 4 weeks.
Excellent. Thanks so much for having me on, and let's hope the world doesn't end between there. We're in a giant agent attack.
Exactly. Kenzie, bye.